Hey guys, welcome to another video. So today we do another nice question from the Extension 1 syllabus. This time the question is a Combinatorics permutations question. Now, I really like this question because firstly, it's the last question in the Sydney Girls 2022 trial paper, but also it allows me to utilize the divider rule. Now, for those that haven't seen my Combinatorics permutations and combinations videos, please go see them because I'm going to use one of the techniques today that will allow me to do the last question because I looked at the answers. To be honest, it took me a while. I think the divider approach is much better and much faster. So I'm going to show you that in a second. But before we do that, can you please, if you haven't already done so, please subscribe to the channel, like the video, and tell your friends. Guys, let's get started. So now this question, Sydney Girls 2022, is a nice question, right? Last question, by the way, last 2 marks of the 3 in a paper. So the letters of the word, now let's highlight as we go. Dumbwaiters, yeah, interesting choice of words, are arranged random. Now, I'm thinking, let's have a look. There's no repeats, right? D-U-M-B-W. Yeah, I think maybe they chose dumbwaiters because there's 11 letters there. And there's no repeats. Okay, cool. Find the probability that the word weird appears in the arrangement so that the letters are both in order and together. So in order and together. For example, they give you an example. That's nice. Okay, weird is there in order. Perfect. Part 3. So I think it's a typo in terms of the letters. It says part 3 and part 4. There's only 1 and 2. So there's only 1 and 2, which is these two. So if you sort of ignore that, call that number 1. Call that number 2. I didn't realize there was a typo in the actual question paper itself. The letters of the word weird appear in arrangements that the letters are in order, but not all together. Not all together. So they're separated. So okay. So maybe I'll do them fully. Yeah, I'll show you how to do them. Now, this one here is a good candidate for the divider method. Right, and I'll explain when I get there, but let's do part 1 as well. Part 1's really easy. By the way, they're both worth one marks, which I think it's actually quite unfair. I think part 1 is worth 1 mark, but part 2, at least 2 marks. But I suspect it's the last question in the test, and it's probably one of the hardest ones. They're expecting everybody in their school to get it wrong, so they didn't want to punish them too much, so they gave it 1 mark. But I think it certainly warrants at least 2 marks. Now, for the first one, right, we got the word weird in this order, right, as a block, so they belong together. And how many letters are there outside? 1, 2, 3, 4, 5, 6. So I've got 1, 2, 3, 4, 5, 6 outside. Now, for those that have seen the other videos, right, we know that there are 7 items here, right? So we treat the word weird as a collective, in which case 7 things to arrange, 7 factorial. Generally speaking, thereafter, we basically allow for the fact that these letters can move inside the box, but they have to be in that order. So I can't really arrange them. In fact, that's my answer, right? Just 7 factorial. So we treat the word weird like an individual letter that can move along with the other 6. So actually, my answer there is 7 factorial. 1 mark. All right, piece of cake, 1 mark. Oh, actually, let's have a quick look. They're asking for find the probability, right? Probability. So I need this over total, right? Now, total, obviously there's 11 letters, no repeats. So total, yeah, it would be 11 factorial. So therefore, the answer should actually be 7 factorial on 11 factorial. Now, I believe if you punch that in the calculator, 7920, right? Nothing too hard about that, hopefully. Guys, question number 1, that's done. Now, I like number 2 a lot. All right, I like number 2 a lot. Yeah, because I'm going to use the divider method to help me do this. So for those that haven't seen dividers, right, the dividers is a really cool way that if you had things that were to be placed, let's say, for example, I have, actually, I was going to refer you to the video, but the quick maybe breakdown. Let's say, for example, I had 4 boxes, right? 4 boxes, and I had to place, let's say, 10 coins, right? 10 identical or different coins. 7, 8, 9, 10. So goes. First question for this question, illustrating the divider method. If I had 10 coins, different coins, to place into 4 separate boxes, how many possible outcomes are there, right? How many arrangements are there? Now, you can imagine that it's quite difficult because you can say I got 4 in here. You can say I got 3 in here. You can sometimes say I got none in the first one. Blah, blah, blah. How do you actually do it? Now, the way to do it is basically, right? You got 10 objects. Introduce it. See how there's 4 boxes, which basically means there's 3 dividers in between. And then once you do that, you basically have 10 of the coins to arrange, but also 3 of the dividers because the dividers can move. And the beauty about the divider method is when the divider moves, it basically allows you to have like 1 coin in the first one, blah, blah, blah. So for example, if I move the divider over here, right? 1 coin's in the last one, 5 in the second one there, 2, 2 sort of thing. So the divider is a cool method to illustrate that there are 4 spaces that you can place coins at, right? So, and then the divider can move, right? So what that means is to do this question specifically, I got 10 coins and 3 dividers, so 13 objects to basically arrange. And then all you got to do is basically divide by 3 factorial, which represents the fact that the dividers are repeat. Now, if you haven't seen the video, go see the permutation video because this gets explored. And I did a past paper question from the CSSA using this method where the solution itself was really long, but the divider method knocks it out in like 1 line of working out. Right? And actually in this question, we do exactly the same thing because I can see in the solutions, there's a few lines of working out. In fact, the lines are working out. Sometimes it doesn't make sense, right? So yeah, I guess what I'm trying to say is divider method is much better. So let me now get rid of this concept, get rid of it and do this question. So how do I use the divider method here? Now, I know that the letters W-E-I-R-D, weird, are in that order. So W-E-I-R-D, right? And the other letters, other 6 letters sort of go in between, right? Like 2, 3, 4, 5, 6, right? Sort of thing, right? So what does that mean? The letters W-E-I-R-D become the dividers, right? So if I sort of go, this guy's a divider, 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 I've got 5 dividers and 6 objects to arrange, right? Does that make sense? So basically, what I'm expecting to do here is that I've got 11 objects to arrange, but then I divide by the 5 repeats, which are the dividers, right? So for those that know factorials, right? That's like, 11 times 10 times 9 times 8 times 7 times 6, because the 5 factorials will cancel out, right? Now, if you looked at the solutions, right? That's exactly what they say. And I'll drop the solutions in a sec, right? But once you get that, what you gotta do is also, once you get that answer, right? 11 factorial and 5 factorial, the question says, yep, within that order, but not all together. So from this answer, you actually need to minus when they're all together, which is actually part 1, right? So your answer is therefore 11 factorial on 5 factorial minus 7 factorial, right? Because that's the number of times they are together. Don't want that, right? And then that's the number of outcomes. And if you want a probability, you just got to divide this all by 11 factorial. Oops. Yeah. And once you do that, hopefully the answer is 13 on 1584. And that's it, guys. That's nice. Now, just for you to see what the answer sort of says as well, I'm just going to paste it into the document right now, right? See how they sort of try to illustrate W-E-I-R-D, which is the same as the dividers that I have here, right? And then they sort of go, well, first letter goes into all these places with 6 for the first letter, 7 choices for the second letter, 8 choices for, I mean, I don't really know how to explain that intuitively, and I don't really know how they got those numbers, but to be honest, once you use the divider method, you really don't care about this, right? But what is important though, is that 11 times all the way to 6 is the same answer that they got over here, and then they minus 7 factorial, which is the number of outcomes that they are together. Guys, use the divider method. How do I know to use the divider method? Basically, in this one, I had W-E-I-R-D as the separators. And if they're the separators, you basically consider them to be a divider. And once they're a divider, you have to divide by the fact that you assume that all the dividers are identical. So we divide by 5 factorial in this case, which is like a repeat, right? Then you get the answer. Hopefully that was okay. Like I said, if you want more examples on the divided method, please see my other videos. Otherwise, guys, subscribe to the channel, like the video, and tell your friends. Thank you very much.